Welcome to another chalkboard session by www.electricalpereview.com. In our first video on complex numbers, we covered going back and forth between polar and rectangular. In this video, we'll be covering mathematics with complex numbers. So let's jump right in. Addition and subtraction will always be done in the rectangular form. Multiplication and division will always be carried out in polar. Let's say we've got two vectors. Let's say we've got two vectors, x and y. X in polar is going to be Rx at an angle of theta x, and in rectangular is going to equal Ax plus j bx. And for our vector y, same thing. Y is going to equal Ry at an angle of theta y, and in rectangular, our real is going to be Ay plus our imaginary j by. So carrying out an addition of subtraction is going to look something like this. X plus y, we're going to add the real and imaginary components together to form our new vector. Ax plus Ay would be our new real, and j bx plus by will be our new imaginary. Now let's look at subtraction. X minus y will be Ax minus Ay plus j bx minus by. Notice that we're still going to have a plus sign in between. However, if this comes out being negative, that is if by is greater than bx, then this of course will turn to a negative number, and we'll see that in the example. Similarly, y minus x is the same thing as Ay minus Ax plus j by minus bx. Now let's look at multiplication and division. X times y is the same thing as multiplying our two magnitudes, which is Rx times Ry, at an angle of, here we're going to add our two angles, theta x plus theta y. Similarly, for y times x, you'd get the same value, but it'd be Ry times Rx at a phase angle of theta y plus theta x. And of course, these two are exactly the same. Now division gets a little different, so let's look at first x divided by y. This time we're going to divide our magnitudes, so Rx divided by Ry. However, instead of doing multiplication like we did on the top between the angles, we're going to subtract them. And it's always going to be the top angle minus the bottom angle. So theta x minus theta y. For y divided by x, just like above, this time we're going to have our y magnitude divided by our x magnitude at an angle of the top angle minus the bottom angle. So theta y minus theta x. Now, anytime if you're given, say, a vector in polar, x equals Rx at an angle of theta x, and you're carrying out a problem and you actually have to add this to a rectangular vector, say Ay plus j by, we know we can't carry this out with one in polar and one in rectangular. So this is really x plus y. What you'd have to do is convert this, our x vector, to rectangular first. So Ax plus j bx plus Ay plus j by, and then carry it out. Similarly, if we're given a vector in rectangular and polar and asked to multiply or divide, you'd have to convert the rectangular vector into polar. So say we're asked to do y divided by x. You're carrying out your formula, solving, say, for complex power, and you end up with something like this. Y in rectangular, ay plus j by divided by x in polar, rx at an angle of theta x. Before you can carry this out, you'd have to convert the rectangular vector into polar. So you'd do your math and you'd come up with ry theta y divided by rx with an angle of theta x. And we could carry this out just like we did above. Ry divided by rx at an angle of theta y minus theta x. If this seems a little confusing, don't get too hung up about it. We're about to do a couple examples and it's going to make it really simple. The key thing to remember is anytime we're dealing with addition or subtraction, it can only be done in the rectangular form. And if we're given any vectors in the polar form, we must always convert them to the rectangular form first. And anytime we're doing multiplication or division, it can only be done in the polar form. And if we're given any vectors in the rectangular form, we'll have to convert them to the polar form first. That's it for this video. Stay tuned, and we're going to do a couple examples of addition, subtraction, multiplication, and division using complex numbers to give you some practice. For more sample problems and our premium review course, please visit us at www.electricalpereview.com.